Okay guys, welcome back. So in the last video we talked about finding the asymptotes, the horizontal asymptotes and the vertical asymptotes. Now in this video I will be talking about two practical examples in which how we can find the horizontal asymptotes. So you know how to find horizontal asymptotes. Now let's take two more examples. Now I discussed some examples in my last video, or the video on asymptotes and the horizontal asymptotes. So I'll take two more examples so that you will get a broader aspect or broader understanding of this concept. So I'll take the first example to be like this. So if I were given something like this, fx equals 3x squared plus 5x plus 6 divided by x plus 2, right? Some function like this. What are the horizontal asymptotes of this function? Alright, so in order to find horizontal asymptotes, as I mentioned in the theory part, you have to actually differentiate what happens when the limit of x goes to infinity, right? Limit of x goes to infinity, what are the values that you will get for fx? So what I'll do is we have to take the limits of both sides, because this is an equation. So limit of when x goes to infinity fx equals limit when x goes to infinity 3x squared plus 5x plus 6 divided by x plus 2. Now I actually discussed this in one of my previous videos as well. So if you are not well versed with that, I invite you to watch those videos and come back. So you know, now this is the value we have to find here. So we have to find the right hand side. So you know that if you are given some function like this, some limit like this, if x goes to infinity, and this is a quotient function. So you know what we have to do is that we have to divide both the numerator and the denominator by the highest power of the denominator. Now the highest power of the denominator is 1, because there is only one expression of x, and that is also equal to the power of 1. So the highest power of the denominator is 1. So what actually happens is that if the highest power is 1, we have to divide both the numerator and the denominator by x to find the limit, this limit. So this is equal to the limit when x goes to infinity. So 3x squared divided by x is equal to 3x plus 5x divided by x is equal to 5 plus 6 divided by x is equal to 6 upon x divided by x divided by x is equal to 1 plus 2 divided by x is equal to 2 upon x. So you know that if you have some function like this, if you have a quotient function like this, you have to take the limits of the numerator separately and the denominator separately with the quotient included. So this is also equal to limit when x goes to infinity 3x plus 5 plus 6 divided by x divided by the limit when x goes to infinity 1 plus 2x, 2 divided by x, right? 1 plus 2 divided by x. So you know that if you have a function like this, now this is a function, right? If you have something like this, what actually happens is that you have to find the limits individually. Now there are all these additions. So you can take the limit when x goes to infinity of 3x, limit when x goes to infinity of 5, limit when x goes to infinity of 6 divided by x, and you can add those limits up. So that's the numerator. And for the denominator, you can say limit when x goes to infinity of 1 and limit when x goes to infinity of 2 by x, and here's an addition, so we have to add those, and that's the denominator, and you get a value for the limit in the numerator, you get a value for the denominator, you divide those two to find the limit of fx when x goes to infinity. So if you get some finite value here, those are you get some value here, those are the horizontal asymptotes of this function. Alright. So when x goes to infinity, 3x will also go to infinity. So this is infinity plus when x goes to infinity, whether x goes to 5 or x goes to 10 or x goes to 100 or 1000 or anything, or whether x goes to infinity, the value of 5 will be the same, right? Plus when limit when x goes to infinity, 6 divided by x will be 6 divided by infinity, which is equal to 0, divided by 1 plus, so limit of when x goes to infinity of 1 will be 1, plus 2 divided by x is 2 divided by infinity, which is equal to 0. So you know that 5 plus 0 is 5, so infinity plus anything is infinity, because infinity is a very large value, whether you put 5, not 5, even 5,000, 50,000, 5 million or 5 billion, infinity plus that value is equal to infinity, so the numerator will be infinity, and the denominator is 1 plus 0 is 1, so infinity divided by 1 is infinity. And that is the infinity is the only horizontal asymptote that you will get for this function if x equals 3x squared plus 5x plus 6 divided by x plus 2. So the horizontal asymptote is only the infinity. Right. So let's take another example in which we have to find the horizontal asymptotes. So I'll take it to be an easy one here. Fx equals, right? Fx equals x cubed plus 5 divided by x cubed plus 8. So if you are given something like this, so and in order to find horizontal asymptotes, it's the same as the first example. You have to take the limit when x goes to infinity of both sides and solve the right hand side. So the limit when x goes to infinity, fx is equal to the limit when x goes to infinity, x cubed plus 5 divided by x cubed plus 8. So you know by concepts that if you are given something like this, as I mentioned in the last videos, and I have been talking about the series of videos on limits, if you have some infinitive limit of a quotient function, what you do is you have to divide the numerator, both the numerator and the denominator, by the highest power of the denominator. So the highest power of the denominator is 3 here. So you have to divide both sides of this, the numerator and the denominator, by x cubed. So this will be the limit when x goes to infinity. So x cubed by x cubed is equal to 1. 1 plus 5 divided by x cubed is 5 upon x cubed. 5 upon x cubed divided by x cubed by x cubed is again 1, plus 8 divided by x cubed is 8 upon x cubed. So this is 8 upon x cubed. So as I mentioned in the last example, you know that if you have something like this, you have to take the limits individually, the limit of the numerator and the limit of the denominator. So that will be the limit of when x goes to infinity of 1 plus 5 divided by x cubed divided by limit when x goes to infinity 1 plus 8 divided by x cubed. So that is equal to, now you know that when now you have something like this, you can now, if you have an addition inside the limit, you have to take the addition of the limits. So when x goes to infinity, 1 will be 1. So that will be 1 plus limit of 5 divided by x cube when x goes to infinity. So when you substitute the value of infinity here, 5 divided by infinity is 0, so that will be 0 divided by, so limit when x goes to infinity of 1 will be 1 plus limit when x goes to infinity 8 divided by x cube, 8 divided by x cube will be 8 divided by infinity, which is equal to 0. So the numerator will be 1, denominator will be 1, so the value will also be 1. Right? So the only horizontal asymptote that is available here is 1. So if you draw it in a Cartesian axis, this is the x-axis, this is the y-axis. So 1 is the only horizontal asymptote that is available for you. So this will be like this. Right? So 1 will be the only horizontal asymptote. So if you draw some function like this, here you will skip this line, and then find the graph, or then draw the graph, or find other things that you need for the problem. So these two examples are examples in which you have to find the asymptotes, so the horizontal asymptotes. So in the next video I will be talking about two examples in which you have to find the vertical asymptotes. See you then.